ready for the next talk. Matthijs, please, Daelman. Matthijs obtained a master's degree in environmental engineering from Ghent University in Belgium, not very far, just a couple of years ago. And after graduation, he started a joint PhD at Ghent and Delft, under the supervision of Professor Eveline Volcke and of Professor Mark van Loosdrecht. Is that correct pronunciation?
Yeah, more or less.
More or less.
Thank you.
Can you pronounce fraternali?
Fraternali.
Okay, that's much better than my pronunciation. So he's now, let's say, focusing his research on greenhouse gas emission from municipal wastewater treatment plants. And this is probably the subject of the talk.
Indeed. Yeah, thank you. So the title of this presentation has already been mentioned. I'll briefly give a layout of my presentation. I'll first give you a brief introduction. Then I'll provide the objective and the rationale of our study. I will tell you something about the long-term online measurements of N2O we did ourselves. Then there are two basic topics of this presentation. First, there is an evaluation of sampling strategies that have been used in previous studies. And then I will tell you how we were able to express precision of sampling strategies as function as of the number of samples or the length of a sampling campaign. And in the end, I will share my conclusions with you. So most of you are probably well aware that greenhouse gases are emitted from wastewater treatment plants. The first one is CO2. CO2, but this is a greenhouse gas only in as far as it is related to fossil fuel consumption. Then there's methane. Methane is produced in anaerobic conditions, such as during sludge treatment, but methane also enters a wastewater treatment plant after it has been formed in the sewer system, and subsequently it can be stripped from the plant. But today I will talk about nitrous oxide. It's a very powerful greenhouse gas. 1 kilogram of nitrous oxide traps as much heat in the atmosphere as 300 kilograms of CO2. In the previous study, I found out that nitrous oxide can contribute to about 80% to the climate footprint of a municipal wastewater treatment plant. And usually it's produced during the biological nitrogen removal, which happens by nitrification and denitrification. Here you can see an overview of some previous studies on nitrous oxide emissions from the past 2 decades. And in all of these studies, nitrous oxide was measured at a municipal wastewater treatment plant. The sampling strategies used by these researchers differs a lot. Some measured for only 1 day, while others measured for 1.5 years. Others just took a single grab sample, while others measured online. So there's a difference as far as the period of sampling is concerned, but also the frequency of sampling. The objective of this study was to illustrate the effect of sampling strategies on the estimation of the nitrous oxide emission from a municipal wastewater treatment plant. That's because there is an increasing concern about climate change, so there is a need to report greenhouse gas emissions, but as yet there are no predictive models available. So measuring is in fact the only option. But given the enormous variability, and I will show some examples later on, given this, the enormous variability of the emission, sampling strategy will obviously affect the estimate. And we tested different sampling strategies by applying them to a long-term data set of online nitrous oxide emissions that we obtained ourselves. I will briefly explain how we obtained this data set. Over here you can see the wastewater treatment plant of Kralingse-Veer. It's near Rotterdam, and it's completely covered. So we were able to sample the entire off-gases coming from this plant. We did this for about 18 months, so it's almost 1.5 years. For the concentration of nitrous oxide, we used an online infrared gas analyzer, and we measured the volumetric gas flow rate using an anemometer. So we are able to come up with the nitrous oxide mass flow rate coming out of this plant. Over here you can see the raw data. It shows all the nitrous oxide emission data points from the beginning till the end of our campaign, 16 months. You can already see that there's a lot of variability here. The average emission from these data points was 91 kilograms per day. So keep that in mind for later on for comparing our strategies. So what do we do? From the previous studies I showed on the previous slide, we distilled 4 scenarios. So you can go out to a wastewater treatment plant, install your equipment and start measuring for 24 hours, online measurement. You can do that for 7 days. One of the studies just went to a wastewater treatment plant and just took a single grab sample and analyzed it back in the lab. While another strategy took a weekly grab sample every week we applied this to the entire data set, so 16 months. We simulated these scenarios using our own data set, and we put the results in histograms to compare them. For instance, how do we proceed? For instance, a single grab sampling strategy, well, in that case we considered every data point that was taken between 9 and 5 during a working day as a possible estimate of the nitrous oxide emission of a study. Over here you can see 3 histograms. These are for the short-term sampling campaign, so 24-hour online, 7-day online, and a single grab sample. The vertical line indicates the true emission of 91 kilograms of nitrous oxide nitrogen per day. And as you can see, there is a rather high chance to come up with a very low estimate. So from these histograms, you can, if you look closer, you can see that the chance to end up with an estimate of 50 instead of 91 is almost between 50 and 60%. While the chance to end up with a very high estimate of 200 or 300 kilograms of nitrous oxide per day is in fact not that much lower than the chance to end up with an estimate that's near close to the actual true emission. If we take a look at the long-term sampling strategy, so going out to a wastewater treatment plant every week and take a grab sample, then you can see that the chance to end up with an estimate is fairly high. To end up with an estimate near the true emission is fairly high. So the bins have the same width, 10 kilograms per day, and nearly all of the estimates fall within, let's say, 20 kilograms of the true emission. So long-term sampling, even though it's only on a weekly basis, it's more precise and more accurate than short-term to get an idea about the overall nitrous oxide emission coming out of your plant. That's because, if you take a look at this graph, you can see there is a lot of seasonal variability. The bars indicate the emission and the dots is the temperature. And in fact, temperature is the only external variable, governing all the other variables on a plant. So if you want to sample nitrous oxide emission, there's probably a high chance that nitrous oxide emission has about the same variability as your temperature. So you have to cover the entire range of temperature that you expect to encounter. So you have to measure for long term, in this case more than 1 year. So long-term sampling strategies perform okay if you want to know the overall nitrous oxide emission. However, for certain purposes, you want to get an idea about the diurnal or like short-term variability of the nitrous oxide emission, and this is in fact this plot is in fact a detail of the raw data I showed previously. It shows the online nitrous oxide emission for 1 week in December 2010. You can see the vertical grid lines indicate midnight. Emission is very high at night and very low during the day. This is something you cannot see if you go out and measure if you use a weekly sampling campaign. So this illustrates that there is a need for online monitoring if you want to gain insight into the variability, the short-term variability of the nitrous oxide emission. And these are very useful data if you want to compare with other variables at the wastewater treatment plant, such as nitrogen load, the oxygen, dissolved oxygen, etc. So therefore you need this kind of data. Now you could say, you can go out to a plant and monitor for 24 hours online, then you get a picture of this, or for 1 week for instance. But you could repeat this, so then you also are measuring online over a long term. So then you have to ask yourself, how often do I have to go to a plant and sample for 24 hours online? And that's something we did in the next part of our study. We tried to express how many periods of 24 hours online sampling, 7-day online sampling you need to obtain a certain precision, or the amount of completely random grab samples, or how long does a weekly grab sampling campaign have to be to get a certain level of precision. So again, we simulated these scenarios by applying them to our own data set. For instance, if you take 20 random periods of 24-hour online of our own data set, you end up with a certain estimate. You can do that for 25 days as well, 30 days, and so on. And for each number of days, you can calculate the relative error. And we simulated this 1,000 times. So for each, for instance, number of 24-hour periods, you have 1,000 relative errors. And we use the mean plus or minus 2 times the standard deviation as a measure for uncertainty or for precision. And we were able to plot this. And over here, you can see this plot for the 2 short-term sampling strategies of 24 hours online, 7-day online. So what you see here, over here you can see the number of 24-hour online periods you have to sample, and over here you can see the mean and plus or minus 2 times the standard deviation of the relative error. And if you want to obtain a relative error that's 95% of the cases, less than 50%, then you have to go out and use 25 days of online sampling. If you want to have this for the 7-day online period, then you need in fact 12 weeks spread randomly over the year to obtain an error of 50% and 90% of the cases. We also did this for the other sampling strategies, for the weekly grab sample and for the random grab sample. What you can see here, if you use a weekly sampling campaign of 60 weeks, so you take a sample every week during 60 weeks, then your precision will be like 25%. The 95% of the relative errors will be within 25%. But you can never obtain this if you just go out to the wastewater treatment plant and take completely random samples. However, if your resources are limited and you can only take 30 samples, for instance, then you can see that in the weekly the random grab sampling campaign, we obtain an uncertainty of about 50% of a relative error. Well, this is much higher for the weekly grab sampling campaign. So a random grab sampling campaign, if you have a limited resources for a limited number of samples, it's better to sample completely random than just to plan your samples in consecutive weeks. That's of course because if you have only 30 weeks, then you will not cover the entire variability that you will meet on the wastewater treatment plant. So short-term sampling in fact ignores the long-term variation. So long-term sampling is required if you want to quantify the carbon footprint of your plant, if you want to know over an entire year how much nitrous oxide is coming out of this plant. However, if you want to know more about mechanisms underlying these emissions, then you need online sampling to acquire these online patterns of the emission, and you can compare this with other data. Finally, we show how we express precision as a function of the number of samples or the length of a weekly sampling campaign. And information like this can be used as a guideline for planning further sampling campaigns in the future. Thank you for your attention.
There is time for questions, so please.
Stefan Weijers, Waterschap de Dommel in the Netherlands. In Kralingse Veer, and some occasions you have a covered plant, then you can do off-gas analysis. Do you have any suggestions what to do if you don't have? What's a typical situation?
Well, usually in that case, like a floating hood is used. But then, the problem with the floating hood is you will Of course, you will also have this temporal variability, but then you will probably also have the spatial variability. So you have an extra concern, because the nitrous oxide will be different on different places of your tank. So I think it's a very fortunate situation to have a covered plant, but indeed sometimes you have to resort to floating hood, for instance. But then you have to take care also of the spatial variability.
Any suggestions for that? Or is this going to be the next presentation?
I don't know. No. Yeah, but then you have to make sure that you cover the entire. Then you have to make some instead of a temporal scheme, you also have to make a spatial scheme for covering the spatial variability in your reactor. Indeed. Yeah.
Stefan Winkler from Vienna University of Technology. How did you validate your online data?
We validated them a few times with taking grab samples that were controlled on the lab with the GC. And also our equipment was calibrated, like monthly, but it was checked more often. But real calibration only happened like once a month because the drift was pretty low. Yeah.
And the second question, in your random sampling, did you consider the operating hour restrictions of such a plant? Because
yeah.
Okay.
It was between 9 and 5 on working days. Yeah.
Jeroen Langeveld, Delft University. Interesting presentation. I wonder how the process configuration of Kralingseveer influences the results. Can this be extrapolated to other treatment plants? Or?
Yeah, that's something you have to take in mind. The things I presented here, it's valid for this Kralingseveer wastewater treatment plant, and it has in fact a very specific configuration. But yeah, it's the only thing we can do. We don't have any long-term online data sets available for other plants. But this information can warn you for the caveats you will meet on other plants, of course. Yeah, but it would be interesting to have similar data for other plants, of course. Yeah.
Another question?
Yes, one more question. Last week we had a meeting on the climate reporting for how we're doing in the Netherlands with the climate agreement. And one suggestion or conclusion was we have too little knowledge on nitrous gas emissions. What is your suggestion on that? Should there be more research worldwide on that?
Yeah, of course.
Can you? No, but Kralingseveer is a very specific place. Can you comment a bit on that?
Yeah, of course, but you're talking about, in fact, a policy of reporting nitrous oxide emissions, and then you can go out and sample, for instance, every week. Then you just need the overall emission, and you don't need the diurnal patterns. So that's a bit easier. But of course, there's a real need for knowledge about the process variables leading to nitrous oxide emission, because you don't only want to know how much is coming out, but you also want to do something about it. And therefore, you need mechanisms and this kind of knowledge. Yeah.
Okay, that was my question. So there is another question.
Marta Buitenkamp, Anantis. Would you advise that once you have the complete insight in the mechanism, that will influence your way of taking samples?
Well, yeah. If you have complete insight, you can, to some extent, you could use this information for modeling nitrous oxide emissions. Not to come up with a predictive model, but you can, if you know the variability of your other process variables leading to nitrous oxide emission, then you can, if you know these variables and you know the variability of these variables, then you can guesstimate the variability that you will encounter with your nitrous oxide emission. But I don't think it will ever be possible to just make a model, put all process variables in, and come out with a number of nitrous oxide emission. That's going to be tricky, I think. Yeah.
The last one, then we need to go on with the program.
Hi, Martijn Verleuzen, Royal Ascot DEV. In one of your first slides, you shocked us with the 80%. That 80% of the carbon footprint comes from NTO emissions.
Yeah, CO2 equivalents.
Yeah, indeed. Yeah. That was a maximum value because it was up to. Do you also have a more typical value?
Yeah, there's this report by STOA, and there they have much lower values, like 5% something. But yeah, this plant was very exceptional because of its very high nitrous oxide emission. Yeah, but all the plants that I have seen reports of, it's much lower. Yeah, but this proves that it can be as high as 80%. So, yeah.
Thank you.